So today we are going to start a new topic, which is you can say sub part of work energy power, and we call it a vertical circular motion. Okay. So what we do in the VCM? So instead of the motion in a circular in a horizontal plane, now the motion will be in the vertical plane. So we will have a plane like this, and you can suspend the pendulum. And this is called the point of suspension. This is the length. And we are going to assume that the size of the bob which we suspend is very, very small compared to the size of the length of the string. And therefore, we can treat it as a point mass. But the same won't be true in case of rotational dynamics when we have dimensions. So here I'll draw really small to make sure that it's a like this. Now, when you do not impart any velocity, if it is at rest, then you can say the tension acting upward will be equal to how much?
mg.
mg. Very good. So now what happens? If you impart some velocity, it will try to go this way, but the string length cannot be increased. So it has to turn like this, isn't it? So as you project the bob horizontally, in which direction bob will has to move because of the constraint. So because of the string constraint, if you move like this, yes or no?
Yes, sir.
Okay. So now the problem is to move this way, which force should be bigger, T or mg?
T.
So what we need to realize that the moment you impart velocity, the tension changes quickly, instantly. So there is no delay in the change of tension. So when the bob is at rest, then only the equation is T equals to mg. So T is equals to mg when V is 0. But the moment you give velocity, these are not equal. Okay. This idea is clear, I hope so. So
Yes.
what will happen? This bob will move in a circular track, and the length of the string will act as a radius vector, right? Or radius of the circle. So we can confine the radius with the help of length of the string. Certainly, there is no circle. This is just for your demonstration. So the bob will move on this track, but it is not necessary that it will move on this track only. And why it is so? So the moment you cross this horizontal line, the moment you cross the horizontal line, if the bob is somewhere here, let me draw the line here, and let's try to draw the AB. Now the tension will change throughout the journey. It cannot be same always. So let's say the tension here is some value T, or let's call T dash. Let's call this angle as theta. And the gravitational pull will act like this. So what you can see, the tension and the mg are not opposite, rather they have supportive nature in this case. And therefore the net force towards the center is how much? At P, it's A. At A. So at P, what do you think? What will happen? So what is the net force acting towards center? So looking at the APT, you can say what is the net force acting towards the center, right? Tell me. What is the net force acting towards center, Siddhant?
T plus mg sin theta.
Very good. And as you will go up because of the energy conservation, as you go up, the potential will increase. So what will decrease? Kinetic will decrease, right?
Yes.
And therefore, the moment you are here, you will have some velocity. You can name it V. Let's call this as V. And now, as per the dynamics of circular motion, what do we know? The net force towards center is equal to m into V square by R, right? So T is how much? Which means as theta will increase, the first term will decrease because V will decrease as you go up. And as theta will increase, this term will grow. So there is a possibility that this entire term may become zero, right?
Yes, sir.
Now we are talking about the possibility. Now listen very carefully. If this term is zero, then what is the force acting on the bob once tension is zero? Once the
mg
tension is
gravity.
zero, yeah. Once, yeah, mg. So I can say only gravity, not mg. It's only mg, right? Not mg.
Yes, sir.
With T is zero, the only force acting is gravity. And the trajectory of a particle under gravity is which trajectory? Circle or parabola? Tell me.
It's a parabola.
But we are talking about the circular motion, right? So for circular motion to continue, what is the necessary condition? Okay, you don't realize. For a motion to be circular motion at every instant, the tension must be non-zero. So
Yes,
for
sir.
VCM, the necessary condition is at no point of journey, the tension becomes zero. So tension is non-zero all the ways. Always it will be non-zero. So in a way, you can say it is always positive, having some tension. So the string connecting the suspension to the bob must be taut all the time. And if it is so, then we say that it will perform the vertical circular motion. Is this clear? Is this clear?
Yes.
Hello.
Yes, sir.
Now, as you go above the horizontal, there is a chance. But as you go below the horizontal, should we be worried about the tension if we are here somewhere? Do you think we should worry here? What do you think?
So no, sir.
No, because the mg will have the opposite component, right? So if I call this as alpha, this is mg cos alpha, right? Which means tension at this instant cannot be zero because someone is always pulling you away. So someone is trying to stretch the rope. So it will keep it taut. So we should not be worrying about the tension in these two quadrants, right? So we should be worrying in which quadrant? The upper two? Does it make sense to you guys? Yes or no?
Yes.
So where we should be worried maximum? The maximum worry is where? Where the chance of tension to be zero is maximum. See, at the topmost point, the V is minimum, right?
Yes, sir.
and this is maximum. So the difference is going to be minimum, right? Isn't it? Hello, hello.
Yes, sir. Got it.
Which means if I make sure that nothing is going to be zero here, my job is done, right? Isn't it? So the T is acting here, and mg is also acting here, and we do have, or we must have, some velocity here, isn't it? So why we must have some velocity here? Any guess? If I make v 0 at the topmost point, the T becomes negative.
Yes.
And what is the meaning of negative tension? It means it is no longer existing. It is zero actually. It's a loose now. So at the topmost point of the journey, we cannot assume zero velocity. If you do so, you will violate the condition of circular motion. So to make sure that at topmost point is non-zero, what VC must we have? No, that is the question we are trying to answer here. And now it's easy. You can have T plus mg, which is the net centripetal force, if you realize, equals to mvc square by r. Do you realize this? Yes or no?
Yes.
So what is TC at the topmost point? What is TC equals to? And what we want is that this TC must be positive, which means we must have velocity at C, which can provide you the enough centrifugal force exceeding the gravity. Then only we can have tension. Is this clear?
Yes.
Yes.
So if you do so, you can see something interesting. The VC square should be more than GL. All
Yes.
right. So this implies VC must be more than which means only if the VC is more than root GL, only if the VC is more than root GL, we can think of complete circular motion. So what if VC is less than root GL? What will happen? I mean, what does it mean? Not what will happen, what does it mean?
It won't complete the circular motion.
Which means it will never reach the C point actually. It will be, the tension will become zero in this quadrant somewhere. Somewhere here, the T becomes zero, and you will never reach the point C. So generally, when we solve question, we always talk about the minimum value. So what is VC minimum? For VC minimum for complete PCM. What do you think? The minimum should be numerically equals to root GL, right? Numerically.
Yes, sir.
So it is like this plus 0.0001, but that's like as good as saying root GL. I hope this is clear. Hello guys, is this clear?
Yes, sir.
Yes.
So the moment you realize that at the topmost point of the journey, we need a velocity of value more than equal to root of GL, you can actually guess what velocity we need at the bottommost point as well. So once you know the answer for the topmost point, we can actually calculate the V of any other point with ease. Okay. Okay. So now you know that what is the minimum you need here. And the minimum at the topmost point will correspond to minimum everywhere else, right? So what is the minimum we need at A to make this possible? So in the vertical circular motion, you know that as you go up, the kinetic decreases, potential increases. So because you know the kinetic of the topmost point, and you can always write the potential. Can you guys find the A velocity at A using conservation of energy? So using conservation of mechanical energy, what is VA? So we know that the total mechanical at A is equal to total mechanical at C, correct? And you can choose some reference line. So let's say this is the reference, easy for you. So, okay, I think you can tell me the answer. Tell me, Siddhant.
So V is equal to 2 root GL.
No. You have to write the energy conservation. You don't know, right? So the energy
So
at A
V is
is
equal to root MGL into 5/2.
okay. Look at this. So energy you can write half mVA square plus 0 potential. At C, what is the potential compared to the bottom reference? Tell me, Siddhant. Potential at C is how much?
Mg into 2L.
Very good. M. So VA square is VC square plus 4GL. Correct. And what is VC for the minimum case? So VA is how much? Basically VA minimum. I hope this is clear.
Yes, sir.
So VA minimum is how much? Root 5GL. Isn't it?
Yes, sir.
Very good. Okay. So if I ask you the question that what is the V, because at this point the ball will go this way. So what is VB minimum? Can you guess? Tell me. What is VB minimum? To write the energy between B and C or B and A, because now you know the answer of A as well. You will get the answer. So simply write the energy
So
conversion, right?
root 3 GL.
Very good. You derived or you know the answer?
So derived.
Very good. Very good. So if you have derived, it's really good. So Siddhant, you got the answer?
Yes, sir, same.
Same, very good. So we'll get the VV minimum equals to root 3 GL. So now we have done for this standard location that one should be aware of. And it is very easy to remember if you look carefully. It follows the odd rule 135. It means 1 GL, 3 GL. So I hope this is easy to remember, right? The odd
Yes,
rule.
sir.
Okay. So just in case you get confused, from top to bottom, it should grow. So 1, 3, 5. Okay. So what if I ask you this question? So you have done for the bottom, the top, and the horizontal. But if I ask you, can you find the velocity? Okay, if I throw with 5 GL, let's say I'm talking this is the minimum. So what is the velocity at this point as a function of theta? I want this. Find V. I hope this is easy. Convert conserve the energy from A to 1 P. You get the answer. Tell me the answer. How much is V coming? So once you throw with 5 GL, then every V is the minimum, no matter which one you choose.
So is it root GL into 5 minus 2 sin theta?
Yeah, that seems to be correct on this. So we have half mVA square plus 0, no potential. Half mv square plus mgl 1 minus cos theta. Is this what you did?
Yes, yes, sir.
Very good. Then you are supposed to get the right answer. So v square is how much? Minus So 5GL minus 2GL plus 2GL cos theta, right? Which is 3 plus 2 cos theta whole into GL. Is this what you got?
Yes, sir.
Okay. Yeah, person. So you got your mistake. I think you substitute V as 5G, right?
Yes, yes, sir. Got it.
No problem. Okay. So now this is the V, so you can use this as a in general formula. If you put theta equals to 0, you can see the answer is 5GL. And if you put theta equals to 90, how much?
Root 3G.
And if you put the theta equals to 180, this root G, right? 180 is minus 1. Cos pi is minus 1. Okay. Okay. So now we'll do some interesting sum. So we'll talk about something very interesting. So the question to you is, with what velocity we must project just to reach here? So for what V, I want to throw with V, but I want to reach only here up to 90 degrees. So what the V must be? Easy one, just write the conversion here. What is the answer?
Root 2GL.
Correct. So which means root 2 GL is going to take you here only. And why I said you need to know all this, because we can do some guesswork. So case 1, if VA is less than root 2 GL, what will happen?
It will stop somewhere in that quadrant.
So it will always oscillate in the bottom 2 quadrant, right?
Yes, sir.
So if you go here, will come back, and if you give less, it will just oscillate. So it may oscillate from here to here. If it is less than 2 GL, at the worst case, it will go up to here, but it will only perform the oscillation. So if the VA is less than this, what do you say? Motion will be Oscillatory AS2. But what if VA exceed 2 GL, but it is still less than 5 GL? You know what will happen? Can you guess?
So it will go up to the first quadrant and then come, but it will not
Very
cross
good.
the first.
So it will go in the first current for sure, somewhere here. And the tension will become 0 at some random theta, right?
Yes.
Isn't it? But the moment T becomes 0, it will perform which motion? Circular or parabolic?
Parabolic.
So what we say that motion will be partially and partially with the time. And case 3. So it is clear. Motion will be complete VCM, right? It is clear.
Yes.
Okay. So motion will be complete VCM. I hope this is clear to all of you. So let's do one such problem. So imagine a question in which I throw the ball at the bottommost point with V. So what do you think? What will happen? Will it cross this? Let's name it. So will it cross the first quadrant? Yes or no?
Yes, sir.
Yes.
Second.
No.
So how we solve a question like this? Because we know it will never cross the second. We take some random position in the second and we call the angle theta. As of now, we don't know. But this is the way to solve it. And you have to learn this way. And then you draw the free body diagram. Say T, M, G. And you have no idea what is V. Let's call V only. So the step 1 is write the circular motion dynamics. So if you write net force towards the center to what we should substitute here? Can you tell me? So we can write P plus does it make sense to you guys?
Yes, sir.
And we are sure that T will be 0, right? So put T 0. So what is mg sin theta? So whenever the tension is 0 in the quadrant number 2, the V square will have the theta relation like this. GL sin theta in the root. And this is what you will get very often in every question. All right. But once you get the V relation with theta, what is the next step? Conserve the mechanical at A and B. Conserve.
So we have to find theta, right?
Yeah, correct. Because we know that at some angle this will happen. So we need to know at what angle this will happen. Correct? Okay, got the answer? Now, so that
So
they
2
mentioned.
minutes.
So persons are getting the idea what is happening here.
Yes, sir. Sir, is the
Yeah.
answer in terms of L?
Yeah, but no, theta is a number, no? So theta can't be L, right? Theta will be theta only, no?
I'm getting sine theta is 4 minus L by 1 minus L.
No. 4 minus L, no, nothing like that. So I think there's some calculation error. Can you recheck?
Sir, I got theta in the form of sin theta plus cos theta.
No. Okay, you guys are not correct. No problem. Correct. Energy at A is how much? Half M VA square, which is and there is no potential because we can take the bottom as a reference. Energy at the topmost point is how much?
So I'm getting sine theta as 4 minus L by 2.
No, no. Again, there is some error. Okay, what is the potential, Siddhant? Potential is how much?
So L
mg
plus
L
L.
plus L sine theta.
Like this, right?
Yes.
So VA square is V square plus 2 GL. And plus, what is V? So 4 equals to sin theta plus 2 plus 2 sin theta, right? Very famous answer. And because this answer is less than 1, so the answer is definitely less than 90. And this is a valid answer, correct? So you all got your mistake in calculation?
Yes.
Yes, sir.
Good, very good. So once you get this sin theta, then everything you can calculate back actually. So what we can do next is so what we realize that and you realize that at this point it will move under gravity only because T is not there. So this is what angle? So the trajectory will be like this, right? Isn't it? And you also have the maximum, right? This H max. So what is the H max? We know the formula.
Root
V
2
square.
GL.
It is Vy square by 2g, right?
Yes.
And V square is GL sin theta. And we know sin theta, but we don't know cos theta. Let us just put to right. So they will ask you what is the maximum height of the entire journey from the base. For the entire trajectory, how far you can go from the bottom. So what is this value? Y max. You can say Y max is how much? How much? What is Y max? Tell me.
L plus L sin theta.
Plus
Plus 5L by 27.
how much? How much is this?
50L by 27.
And you can realize that this is slightly less than 2, right? Do you realize it is slightly less than 12?
Yes, sir.
Very good. So slightly challenging one. So the challenge is so we have a bob of pendulum. You impart certain velocity which you don't know how much. But you can realize one thing. And at some point theta, that tension becomes zero, which we know the relation, right? So whenever the t becomes zero, the v and the theta will have a fixed relation, right? It is like fixed. The moment you make t zero, this is always the answer, isn't it? Now what they are saying is that after the tension becomes zero, it will traverse the path and will hit the point of suspension itself. Okay. So what is V? So you got the question?
So can you see the previous page for a second?
Yeah.
Done.
Done? You done? Okay, I'll give you the trick. It's very easy to solve. You can solve by the geometry, it's easy for you. X in this point. And this. So in time t, how much you will travel if there is no gravity? Vt, right? And the same time it will fall by half v square. And this is the radius. And this is theta. Yeah. So half gt square cos theta equals to vt. And the second is half, I can say tan theta is L by it is. If you compare these two, you can see even that. So that will be v square equals to GL cos theta. So this is the question. So you can compare the v square. So that is the answer. So much effort. And once you get this answer, then you can add the energy. This is very challenging, not easy. So you can try at home. It's not easy. It's really challenging, but you can try at home. So these are like some of the very advanced questions that we come across, but so if you release from rest from this location, what do you think? It will perform which motion? Oscillatory or circular?
Oscillatory.
Very good. So what we do is we put a peg somewhere there. So once you hit the peg, only the bottom part of the rope will be in circular motion, right? The question is, what is the minimum value of X? We must put the peg. Peg is like a nail, such that once you release from that position, it hits the peg and then performs the complete VCM. So if you say this is X, then this will be how much? Tell me, Sivan. How much is this?
L minus X.
Very good. And what you want, that this must complete the full circle. So the minimum velocity we need is how much? Under 5G
Root 5 here.
R, which is correct.
Yes.
This is the answer which we need. But we know from energy conservation, what is V? So half mv square is mgl 1 minus 4 second, right? Let's take theta is 60. Just to make it easy. So this will give you how much? So V square is how much? Only GL. And what is V square here? 1 and 2 implies so if you put a peg at 4L by 5, it will perform the complete circummotion. Do you regard this question? Yes or no?
Yes.
So now similar to the pendulum problem, we have something called track problem. So let's say there is a block, a tiny block, we know the dimension. And it is given a velocity u. So what is the minimum we must give to reach the topmost point? How much we must give? This is the fixed track. So what is the U minimum?
Root 5G.
Same answer. And if you do so, you will come here and you will have the velocity how much? So
The
V
root
at this
G.
point will be root G. Very good. Which means no need to solve separately. You can implement the pendulum question. It's a similar question. So you can solve, right? The next is next is called U problem. So when you have a tube instead of a rack, and let's say you take two identical balls. And both are released simultaneously from the topmost point. And what you need to realize that this ring is slightly smaller than the ball, bigger than the ball size. So that ball can easily move around without touching the other surface of the ring, or it is a tube actually. So the question is, as you release and as the ball will start traveling, at some point the ball will leave the surface. Do you realize this? Do you realize that it will leave the surface, the inner surface? No. Okay, so before that, we should solve this question. So let's say we have a fixed surface, like this. Fixed cylinder. So we have fixed cylinder like this. And you take a tiny block. So as it will move down the track, what will happen? If you draw the PD first. So we will write the MG. And this is, oh, sorry. And the normal will act this way, right? So how to write the dynamics of circular motion? So you give a gentle push at the topmost point and then it starts moving. But as you come down by theta angle, what is the net force acting towards the center? Siddhant,
mg sin theta minus n.
MG,
Mg cos theta minus n.
N is how much? So as you go down, cos theta will decrease or increase.
Will increase.
Cos theta will increase or theta will increase.
Theta will increase, cos theta will decrease.
Very good. And what about the V? mg square? Hmm?
Sir, even V will increase.
So the normal may become 0 somewhere, right?
Yes, sir.
And it must be 0 before the 90 degree for sure.
Yes, sir.
So that is called the block will leave the surface. It will fly off the surface. So when block leaves the surface, then becomes 0, right? mg so V square is gr cos theta, correct? Similar to the scenario when tension becomes 0, right? GL sin theta, right? So here the theta is with vertical, so it is cos. If you would have taken from the horizontal, it is again sin on. And because it will leave the surface, it will fly up like this. But the moment you put a tube here, what will happen? It will again hit the other side of tube and will move again circle.
Yes, sir.
So this is what we need to realize. So here, the ball will leave surface again at the some time with theta. And it will solve actually. This happens at cos theta goes to 2/3. So conservation of energy will give you V square is 2G. And you can equate these two. With cos theta is. It's a similar answer. So what I'm saying is, at cos square 2/3, you will leave this surface and you will hit the outer surface. So your motion will be on the outer surface, and therefore the tube will feel the lifting force. So this is the normal on the tube. And because of symmetry of the two walls, so when the ball will hit the upper surface, and if I say the mass of tube is capital M, so what is the lifting condition? So let's say it makes some angle alpha. We don't take theta because this will happen at some other angle. So at some angle alpha, actually, it will lift the tube also. So lifting condition is 2n cos alpha is mg. Okay. And what else you can write is for circular motion of balls. For the same ball, the normal will act inside. The Newton's third law, gravity will act this way. So mg cos alpha plus n is mv square by r. And fifth will be conservation of energy. So this V will be actually the V at alpha. So you have to use this relation, this and this to solve. It's too difficult, right? Challenge. So these questions are not for solving now. Actually, I'm just putting in the recording so that when you do the revision of circular motion, you can focus on this challenging problem that time when you are going for the JEE advance and you have already passed the class 12th. Yeah. So not for today. I see I'm teaching just for recording actually. So it's not about that you need to know things like this at this stage. No, not at all. Understood what I'm saying? Maybe partially understood, right? Hello.
Yes, sir.
Okay. So do not worry if you're not able to solve questions like this. That actually problem or something more challenging. Okay, so now you can solve any question of working power. So now try to finish the complete SC Verma. Next lecture I'll keep as a doubt. And then in the next lecture, I will start the chapter center of mass. Okay. So
Thanks.
you have to finish the center mass as soon as possible, as well as rotational dynamics, and then you can move to the class 12 portion. Okay. So bye guys, take care. See you again on Wednesday, right?
Yes.
Any doubt?
Awesome.